Hi, I'm Anna, and welcome back to the D1 Audible cheat sheets. Up to now, we've been looking at what the vine needs and what the growing environment provides. This chapter shifts the focus to human choices, how grape growers decide to work with, manage, or intervene in that environment. Modern viticulture isn't defined by a single philosophy. Instead, it reflects a range of approaches shaped by practical realities: desired yield, target wine quality, cost, labor availability, environmental impact, return on investment, and increasingly, ethics and long term resilience. There isn't one right approach. Each one has advantages and limitations. And most vineyards sit somewhere between categories rather than fitting neatly into just one. Let's start with the approach that dominated much of the 20th century: conventional viticulture. In the second half of the 20th century, grape growing changed fundamentally. Viticulture became more like intensive fruit farming. The goals were clear: increase production, reduce labor, and improve consistency. This was achieved through mechanization, chemical inputs, irrigation, fertilizers, and clonal selection. Vineyards became monocultures, single grape varieties grown over large areas, with weeds removed by plowing or herbicides and pests controlled through regular chemical treatments. There are clear advantages to this system. Monocultures are easier to mechanize. Competition from other plants is minimized. Inputs such as water, nutrients, and treatments can be applied precisely to the needs of the grape variety. Yields are generally higher, and costs per unit of fruit are lower. But monocultures also create vulnerabilities. When every wine is genetically similar and managed in the same way, diseases and pests spread more easily. Nutrients are steadily depleted because there's no natural ecosystem to replenish them. Chemical residues can enter groundwater or the air, creating environmental and health concerns. By the late 20th century, many growers, consumers, and regulators began to question whether this approach was sustainable environmentally, economically, or socially over the long term. That concern gave rise to alternate approaches. Sustainable viticulture. This is the best understood as a framework rather than a recipe. Sustainable viticulture rests on three pillars: environmental responsibility, economic viability, and social responsibility. In D1, the focus is mainly on environmental impact. Sustainable grape growing aims to maintain biodiversity, support natural ecosystems, manage waste, reduce energy use, and minimize chemical inputs without rejecting them entirely. A key principle is understanding the vineyard as a dynamic system. Growers monitor vine growth, weather conditions, and pest populations closely, rather than spraying on a fixed calendar. This allows interventions to be timed more effectively and used only when they're actually needed. Integrated pest management, or IPM, also called lutte raison in French, please excuse my French, sits at the heart of sustainable viticulture. Pests are identified and monitored, thresholds are established, and action is taken only when the economic damage would exceed the cost of intervention. Preventative measures are preferred, but chemical treatments are still available if necessary. The benefits are significant: fewer chemical applications, lower costs, reduced resistance buildup, and better protection of soil and surrounding ecosystems. The main limitation is definitional. Sustainable is not a legally protected term. Standards vary widely by country and region, and in some cases, the bar may be set relatively low. That said, the framework has been widely adopted because it balances environmental care with economic reality. Organic viticulture. Organic viticulture goes further by excluding synthetic chemicals altogether. The core idea is that healthy soils lead to healthier vines, which are naturally more resistant to disease. Organic growers focus on building soil life through compost, organic fertilizers, cover crops, and biodiversity, rather than feeding the vine directly through mineral fertilizers. Cover crops help prevent erosion, improve soil structure, and increase microbial life. Compost adds organic matter and supports nutrient cycling. Hedgerows and biodiversity islands reduce monoculture effects. To manage disease, organic growers rely on traditional substances such as sulfur and copper sprays applied carefully and only when needed. They also use biological controls such as encouraging natural predators or introducing competing organisms like Bacillus subtilis to limit botrytis. The main tension in organic viticulture lies with copper. While it is permitted, copper can accumulate in soils over time, raising environmental concerns, especially in cool, wet climates where spraying is frequent. Certification is another factor. Vineyards must undergo a conversion period and meet standards set by recognized bodies, which adds cost and administrative burden. Yields may be slightly lower, and labor requirements are often higher, particularly in challenging climates. That said, organic viticulture has expanded rapidly, especially in Europe, where consumer demand supports higher prices. Biodynamic viticulture builds on organic practices but adds a philosophical and cosmological layer. Based on the work of Rudolf Steiner and Maria Thun, biodynamics treats the vineyards as a self contained organism connected to wider natural and cosmic rhythms. Farming activities are timed according to lunar and planetary cycles, guided by biodynamic calendars. Practices include the use of homeopathic preparations, such as horn manure and horn silica, applied in very small quantities and believed to enhance soil life and plant vitality. Compost is activated using specific herbal preparations intended to stimulate decomposition and biological activity. Like organic growers, biodynamic growers use sulfur and copper for disease control. Some also practice techniques such as sexual confusion for insect management. Biodynamic certification, most commonly through Demeter, requires organic certification as a baseline and adds additional philosophical and practical requirements. Biodynamics is often associated with small, high quality estates and has been adopted by some very prestigious producers. However, scientific evidence comparing biodynamic and organic outcomes remains inconclusive. In D1, what matters is understanding what biodynamics is, how it differs from organic, and why growers choose it. Regenerative viticulture represents a more recent shift in thinking. Rather than aiming to maintain current conditions, regenerative approaches seek to actively improve soil health, water retention, biodiversity, and ecosystem resilience over time. The vineyard is treated as an agro ecosystem rather than a crop site. Soil health is essential. Healthy soils are rich in organic matter, microbes, fungi, and carbon. Mycorrhizal fungi, for example, form symbiotic relationships with vine roots, improving access to water and nutrients and increasing resilience to drought and heat. Practically, regenerative growers often reduce or eliminate tillage, limit irrigation, increase cover cropping, integrate animals where appropriate, and add compost to rebuild soil structure and biology. Above and below ground, biodiversity is encouraged. The advantages include improved resilience to climate stress, reduced reliance on synthetic inputs, carbon sequestration, and improved long term vineyard health. The challenges are time, uncertainty, and cost. Results are gradual, systems are site specific, and standards are not legally defined. Certification exists, but uptake is still limited. Precision viticulture is not a philosophy but a tool set. It recognizes that vineyards are rarely uniform. Soil, vigor, water availability, and ripening can vary dramatically even within a single block. Using sensors, satellites, or drone imagery, GPS and GIS mapping, growers collect data on soil composition, canopy growth, and vine performance, and interventions such as irrigation, fertilization, pruning, harvesting can then be adjusted at a very local level using variable rate technology. Precision viticulture allows growers to reduce inputs, improve quality, manage variability, and identify different quality zones within a vineyard. The downside is cost. The technology requires significant upfront investment and skilled interpretation, making it most viable for large operations or high value estates. Precision viticulture is often used alongside sustainable, organic, or regenerative approaches. These approaches are not mutually exclusive. A single vineyard may use sustainable principles, organic practices, regenerative soil management, and precision tools all at once. What matters for D1 is understanding why each approach exists, what problem it tries to solve, and what trade offs it involves. Viticulture today is less about following a single ideology and more about making informed choices within environmental, economic, and social limits. I do hope this helps, and I'll see you at the next episode on Chapter 5.